Hey guys, this is Carrie, and in this video we're going to be reviewing the group quiz. So in the diagram below of triangle BYH, angle Y is a right angle. Using the information on the diagram, determine the measure of angle theta. So because this is a right triangle trig problem, we want to be thinking about SOHCAHTOA. So using angle theta as our reference point, this would make the opposite, adjacent. Nope, that's not the adjacent. That was crazy. Still warming up hypotenuse, right? Because it's the longest side across from the right angle, and that would make this the adjacent. So seeing as we have information on the opposite, the hypotenuse, and our angle, we want to be using sine. So sine of theta is equal to 14.9 divided by 16.7. The goal of this problem is to find the measure of theta. So what can we do to both sides so that we get theta alone? Well, we need to get rid of sine, right? So we'll do the inverse function, sine inverse, to both sides. When we do this, we get theta equals the sine inverse of 14.9 divided by 16.7. And we have no way of determining this other than to use a calculator, so luckily I have one on hand, so I'm going to use that. So make sure that you're in degree mode for this problem because we want to find our angle to the nearest degree. So we'll do sine inverse. You can't see what I'm doing here, but I'm just typing in that equation exactly as it was printed. And we get 63 degrees when we round it to the nearest degree. An angle with measure 888 degrees is graphed in the coordinate plane. Whoa, 880 degrees, that's a huge angle. We know it's bigger than a full circle, because that would be 360. So if we subtract that away, because we've already used it, that would give us 528. Now we can actually fit another circle in that 528, so that leaves us 168. And the 168 extra will put us somewhere between 90 and 180. Just filling in the rest of the quadrants here. So it looks like our angle theta is going to have a terminal side in quadrant 2. All right, so an angle of measure negative 125 degrees is graphed in the coordinate plane. So negative 90 would be here, negative 180 is here, so this must be negative 125 degrees. Now a coterminal angle is one who has the same ending side. So we're looking for another angle that ends here. Since these are all positive, if we were to graph any positive angle in standard position, that would leave us with an angle looking something like this. So I'm really curious what this is. Now to calculate that exactly, you can see that together these angles make 360 degrees. So if we do 360 and we subtract off the 125, that will tell us how much the red angle is. That red angle must be 225 degrees. Or 235 degrees if you do the subtraction right. And that's one of our answer choices. Great. An angle theta is graphed in standard position. The terminal side passes through the point 15, 8. That means that our x-coordinate is 15, our height is 8. And actually for this one, I think I'm going to use the coordinate plane formulas. So for coordinate plane, remember that sine of theta is y over r, cosine of theta is x over r, tangent of theta is y over x. So it looks like for most of these, we're going to need to know how much r is. To find r, we can use the Pythagorean theorem. 15 squared is 225 plus 64 equals r squared. Together these make 289. And when we square root that, we get r is equal to 17. So since this is theta here, it looks like sine of theta is going to be 8 over 17, which is right here as one of our answer choices. And you can check the other ones, but none of them are right. All right, next up we've got theta is an angle in the fourth quadrant. So theta ends here. The tangent of theta is negative 3 over 4. So you have all students take calculus. It makes sense that tangent is negative here. To figure out cosine of theta, we want to actually use the same formulas as above. But in order to do this, we need to know something about the coordinates. So because tangent to theta is -3/4, it means that this is our y-coordinate, this is our x-coordinate. So we've got a y-coordinate of 3 and an x-coordinate of 4. But that's not quite right. In order for tangent to end up negative, one of these two coordinates, y or x, would have had to have been negative. We can see from the picture that x is +4, because it's in this direction, and y must be -3, because we went down 3. So lastly, to find r, we do the Pythagorean theorem again, and skipping that step, you'll find that the Pythagorean theorem leaves you with 5 for r. So since cosine is x over r, we'll have 4 over 5. Cosine means it's positive, so we're left with choice 2. For problem 6, theta is an angle graphed in standard position. If the measure of theta is, 5 pi over 3, then which of the following formulas gives the value of sine of theta as a fraction? So for 5 pi over 3, I like to think about this in degrees. Pi is 180 degrees, which leaves us with 5 times 180 over 3. Doing the 180 over 3 leaves us with 60 degrees, which leaves us with the whole thing being 300 degrees. Graphing a 300-degree angle will put us in the 4th quadrant, so all students take calculus. So it looks like in order to find the sine of this big angle, we need to have the sine of our reference angle. Together, the reference angle and the large angle, theta, make a full circle. So to find the reference angle, we'll do 360 minus the full angle, and that leaves us with 60 degrees. So really, we're trying to find the sine of 300 degrees. But what we saw is that the sine of the larger angle is almost the same thing as the sine of the reference angle. For the sine of 60 degrees, we can find that by using our 30, 60, 90 triangle. Depending on which block you're in, we draw this a little bit differently, but as long as you're careful about the sides and the angles being across from the right ones, 30 will be across from 1, the hypotenuse is 2, and 60 is across from root 3. So the sine of 60 is root 3 over 2. Now lastly, because we're in the cosine quadrant, we'll get negative root 3 over 2 for the sine of 300 degrees. So choice 2. Determine the equation of the function graphed below. All right, so this is a mean question in that more than one period was graphed. And so if you look at it, we've got 1. Let's see if I can move that. 1. Nope. I think this will work. 1, 2, 3 periods. So rather than use the information that they gave us, let's find out how long one period is. So one period will be, I guess if 3 of them are 12 pi, then each of them will be 4 pi. So 4 pi, 8 pi, 12 pi. Yeah, that checks out. Notice that I crossed out this mark in the middle. That wasn't because it was a mistake. It's because I actually just find that distracting and unnecessary. It's not very useful for me. All right, so since the period is 4 pi, we can now find the equation of our wave. So since this is a sine wave, we've got y equals, the amplitude is 5, sine, and I'm leaving a blank here. There's no vertical translation, but the reason why I'm leaving a blank is since the period is not 2 pi, we'll have to have a b value there. And to calculate that b value, what we do is we say, when we plug in 4 pi to the inside, it completes a full cycle, which means that the inside has to equal 2 pi. The last step to solve for b is to divide by 4 pi on both sides, leaving us with b equals 1 over 2. The pi's cancel. And so for our final equation here, we've got y equals 5 sine 1/2 x. Determine the equation of the trigonometric function shown below. This one's a little bit mean because it doesn't give us the full period, but it does give us half of the period. And so we can see that the other half would take us to 6 pi, since it will be symmetric. So the period of this graph must be 6 pi. So we've got y equals 2 sine bx. To find b, we plug in 6 pi, and that gives us b times 6 pi equals 1 full cycle, 2 pi. We divide by 6 pi on both sides, and that leaves us with b equals 1/3. So our final equation is y equals 2 sine of 1/3 x. For problem number 9, a sine function increasing through the origin. Always good to have a picture here with these. Can be used to model light waves. Red light has a wavelength of 240 nanometers. Over which interval is the height of the wave decreasing? So if this is 240, the middle would be 120, that would be 60, this would be 180. So where is it decreasing? Well, it looks like it's decreasing from the top down to the minimum value here. And so that would be from 60 to 180. If you look at the other two areas, you can see that it's increasing here and here. And so we exclude this from our final answer. Now these two last problems that were modeling problems have a little bit of a sneaky idea to them that I think you'll see as we go over them. The voltage used by most households can be modeled by a sine function. The maximum voltage is 120 volts. So it's going to go up to 120, and I'm seeing that, let's see, up to 120, down 120. And there are 60 cycles every second. So this is where things get a little bit tricky, actually. If there's 60 cycles every second, then that means in 1 second, we have 60 of these waves. This is a lot of waves. But if 60 of them take a second, then it must be true that each one of them takes 1/60th of a second. And so the period of our wave is not 60 seconds or 1 second. The period of our wave is, since 60 of them fit in a second, each one must take 1/60th of a second. So that's probably the trickiest part of this problem. Now putting it all together, we get V is equal to 120 times the sine of some value B, which we have yet to determine, times t. Now to find that B value, what we do is we say at 1/160 for t, we must complete a full cycle, which is 2 pi. Multiplying by 60 on both sides leaves us with B is equal to 120 pi. So our final answer is choice 4. For number 11, the amount of blood in someone's heart can be modeled using a sine function. A heartbeat means the blood oscillates between a maximum and minimum, like a wave. If the volume of blood varies between 20 milliliters and 80 milliliters, so 20, 80, and someone's heart beats 120 times per minute after running, running accelerates their heartbeat, then which of the following equations can be used to represent the volume V in milliliters of blood in the person's heart as a function of time t in minutes? All right, so let's see. If we waited 1 minute, their heart is beating 120 times per minute. So since they're all sine waves, I'll start at the midline here, and we'll have 120 beats per minute. So a lot of beats, and I can't really draw 120 of them, but it doesn't really matter if I do, because we're not really concerned with that. We're really concerned with how long one heartbeat takes. So if we have 120 beats per minute, then what that means is each heartbeat has to take 1/120th of a minute. All right, so now putting it all together here, we've got our midline is going to be halfway between these, which is 50 with an amplitude of 30. So we've got y equals 30 sine times, not times, 30 sine of b times t plus 50. Now in order to find b, we have to say that b times 1/120 is equal to 2 pi, and then we multiply by 120 on both sides, and we're left with b is equal to 240 pi. And that would give us our final answer here. So the key things with these problems is if they tell you how many times the heart beats per minute, then what you know is that you have to divide that minute into 120 heartbeats, leaving you with a period like this. I hope you guys found this video helpful. See you guys tomorrow.